Hey, let's make sure you have a mask. Tell your friend to wear a mask. Okay, so we are almost finishing the course. So your third exam will be after the last section, which is section 11.1. So once we complete the class, then you do your exam, the third exam. Then also remember your final exam is on the first day of the first Monday of the last the final week, which will be at 3 p.m. 3 to 5 p.m. Let me see. The finals will be on Monday. Is it clear? So it will be on Monday, 13 December, from 3 p.m. to 5 p.m. From 3 p.m. to 5 p.m. And the exam will be in class. The exam will be in class. So the exam will be here. So if you'll be having any issue with your L, then you need to send it 24 hours before the exam. But the classes will be, the exam will be here. Even the third exam will be here. It will be here. So I don't think I will give any exam outside. So I'll give the exam here. Okay, so let's look at section 9.6. This section is so important. So it has a lot of, you can be given one question which is covering section 9.6 and 9.7. Only one question. Which is covering all section.
So weird. I'm just gonna. Wait, what are they talking about? No.
So it is so important. So if you are able to access, you can also access the class in YouTube. So if you don't get anything here, then you can still get it in YouTube. Okay, now let's start. Section 9.6. 9.6. And here we will be talking about the quadratic function. Quadratic function. So quadratic function, we will name it as a function of x, function of x. And this function of x is actually the same as y. It's the same as y. So f of x is equals to y. So basically, is like this. So the elements here, which are take this one as x and this one as y. So the connection which is here is what we call function. So we can have some elements in x which are like x1, x2, x3, like that. Now, to connect it to y, then what we get here are y1, y2, y3. And this y1, y2, y3 is the same as f of x1, f of x2, f of x3, f of x3, f of x3. So these are like now f of x1 equals to y1, f of x2 equals to y2, f of x3 equals to. So I was just trying to introduce what it means by a function. Means by a function. Maybe you have seen this on somewhere. So there are things which we call them if a function is one-to-one, if a function is onto, but it's not so important in this class. It's not so important in this class. What we just need to know is f of y, f of x is equals to what? And y is a dependent variable, and the x are independent. So y depends on x. So y depends on x. So any change in x or any changes in x, they do affect y. So y actually depends on x. So x is independent. It doesn't depend on anything. It doesn't depend on anything. Now, in this case, we can write a quadratic function where a, b, and c are real numbers, and a is not equals to 0, and a is not equals to 0, is a function of the form f of x equals to ax squared plus bx plus c. F of x equals to ax squared. So this is a quadratic function. This f of x, you say, is equals to what? Is the same as y. Y equals to f of x equals to ax squared plus bx plus c. So that is a quadratic function. As long as a is not equals to 0, then it is quadratic. As long as a is not equals to 0. Now, here this function is quadratic. If you graph this function, then it forms a parabola. So it can be of that form when you graph it, or it can be of that form. It can be of that form. So we can write for the graph of the quadratic function, f of x equals to ax squared plus bx plus c. If number 1, a is greater than 0, That means if this one is positive, A is greater than 0. If this A is greater than 0, the parabola opens upwards. So this one is opening upwards if A is greater than 0. If A is less than 0, then it opens downwards. Number 2, if A is less than 0, which is negative, then parabola opens downwards. So that is the first step of sketching or drawing the graph of this function. So one of the things you need to do is identify the kind of graph that you have. If this is minus, then it does what it should be. If it is plus, then it should be opening. For example, determine whether each parabola opens upwards or downwards. Number 1, f of x equals to minus 3x squared plus 2x minus 4. Number 2, f of x equals to 6x squared plus 7x minus 9. So what happens to the first one? So since A is equals to minus 3, right? And this A equals to minus 3 is less than what? 0, right? It is negative, right? So that means this one does what? Opens downwards. So it is of that form. It is of that form. Opens downwards. Now, in this case, since A is equals to 6 and this one is greater than 0, then the graph opens upwards. So it is of that form. It is of that form. That clear? So that is the first step. Number 2, find the axis of symmetry and the vertex of a parabola. So before you graph, yes.
Could you move it over this a little bit so we can see this?
Oh, okay.
Thank you.
Is it clear? Are you guys seeing that? Okay. So so before you graph this again, so the first step is you identify whether the parabola opens upwards or down. The next one is you identify the axis of symmetry and the vertex of the parabola. So let's start from the first one, which is the axis of symmetry. The axis of symmetry. Now, if our function f of x equals to ax squared plus bx plus c, we have that function. Did you guys do guess in high school somewhere else? Differentiation and integration. Has anyone seen something like that? Differentiation and integration. No. So if you differentiate, will not do that. So I'm trying to show you how we differentiate. So we differentiate. There is what we call dy all over dx. I don't know whether you've ever seen something like that. Change in y all over change in x. Okay, never mind. So I will try to show you something here. Don't be mad. Huh? So change in y all over change in x. Here we are differentiating with respect to x. We are differentiating with respect to x. So when you are differentiating with respect to x here, where there is the power of x, you subtract 1, and then you multiply by that power of x here. So in this case, the power of x here is 2. So this is equal to, we bring down 2, which is 2ax. We subtract 2 by 1, okay? Plus, don't even write. I'm just showing you. Plus b, bring down this x here, which is 1, right? 1, and then x raised to what? 1 minus 1 plus c. Our x is 0 here, because anything raised to 0 is what? 1, right? So we bring down 0, which is here, and then we subtract 1 from that 0. Okay? All right, so when we now simplify dy over dx equals to 2x minus 2 minus 1 is 1, right? So 2 raised to x plus x, 1 minus 1 is what? 0. So it remains what? B. And then this is what? The whole of this is 0. The whole of that is 0. The whole of that is 0. See, this is actually calculus. If you do calculus, then you might find something like this. Then we equate this one to 0. We equate that one. Okay, is equals to 0. And then we make x the subject. We make x the subject. So we take this b to the other side. So 2ax equals to minus b. And our x equals to minus b all over 2a. B all over 2a. This is actually what we call maximum and minimum. So this x equals to minus b all over 2a is the maximum point on this graph, or the minimum point. So if it is facing down, then this is the point which is that point x equals to minus b all over 2a here, where it is turning. It is where the gradient at this point is 0, and the gradient here is 0. If you still remember, change in y all over change in x, we said that one was what? The gradient, right? We did something like that in section, was it section 3 point something? So we said change in y all over change in x is equals to what? Is equals to m. This is the same thing. Change in y all over change in x is the same as a gradient. Now, at this point, that gradient, change in y all over change in x, is equals to 0 at the point where it is turning here. Is equals to 0. And that point is what we call the axis of symmetry. The axis of symmetry. The only thing that you need to remember here is this formula. You don't have to remember this. This formula here, x equals to minus 2a minus b all over 2a is the axis of symmetry. The axis of symmetry. So we can say the axis of symmetry is a vertical line x equals to minus b all over 2 minus b all over 2a. So x is, so it is a line which is passing through that point. And the point there is where the line will pass through at the x equal to something. So it is a line. So the axis of symmetry is now the line which subdivide this parabola here, so that this point is equals to this side. So it is symmetric. So this side is the same as this side. So this one is the same as this. So this is now x equals to minus b all over 2a is the axis of that symmetry. Now the point here, so it actually passes through the point which is turning here, which is actually turning. It's similar to this. Also, this is also the axis of symmetry. So if it is like that, so this is a parabola which is facing downwards. So the point here is the maximum point, and also when it is facing upwards there, this is, we can call this one is minimum point. You don't have to remember those terms. So the line which passes through this point and this side is similar to this side. It subdivides this parabola here. So this is the parabola. So this line which passes through the middle here is what we call the axis of symmetry. And the point that passes through that line here is what we call the vertex. So the point here is the vertex. And we actually get this vertex from the axis of symmetry. Now, once we have gotten the axis of symmetry by using this formula here, then we now come and substitute this x in the function. So now our function f of x is equals to ax squared plus bx plus c. Now to get the point here, then we come now and substitute this value of x equals to minus b all over 2a here. So our f of minus b all over 2a, we substitute them here. Where there is x, you put minus b all over 2a, which is a minus b over 2a plus b minus b all over 2a plus c. So this is now giving us the y at that point. Now the vertex of that line will now be the point which is this axis of symmetry, which will be minus b all over 2a. And now this one which we have substituted here, which is f of minus b all over 2. This is what we call the vertex. The vertex. So we'll see an example of this. Let's look at an example. Example. For the graphs f of x equals to 3x squared minus 6x plus 2. Find the axis of symmetry and vertex. Find the axis of symmetry and vertex. Now, before we continue there, so what is the shape of, where is it facing? Upwards, right? So since the solution, since a is greater than 0, then parabola faces this way. So it faces. Now, what is the axis of symmetry? Now we have this function f of x equals to 3x squared minus 6x plus 2. So our a here is equals to what? 3. Our b is equals to what? Minus 6. And our c is equals to 2. C is equals to 2. So the axis of symmetry, we say our axis of symmetry x is equals to minus b over what? 2a. Make sure you remember this formula. The axis of symmetry x is equals to minus b over 2a. So our x will now be minus, our b is minus 6 all over 2. Our a is 3. So this is equals to 6 all over 1. And this one is equals to 1. That is equals to 1. So that is our axis of symmetry. Now, what is our vertex? Vertex. So our vertex will now bring this axis of symmetry x to this function here. So our function f of x equals 3x squared minus 6x plus 2. So our other point is f of now 1 will be equals to 3, 1 squared minus 6, 1 plus 2. And this one is giving us 3 minus 6 plus 1, 2. And this is equals to 1. So minus 1 is equals to minus 1. So our vertex in this case will now be, is now x and this. So 1 and minus 1. And minus 1. Any question? So that is our vertex. Now, when you come now and sketch, so it means our axis of symmetry is where? At x equals to what? 1, right? At x equals to 1. And where is the point which is turning? 1 and negative 1. 1, so there is negative 1 here, and there is 1 here. So let's take that point as the turning point. And we say this is facing where? So this one is axis of symmetry here. So it passes through that point. And then now it is doing what? Facing where? So it is facing. So this side is symmetric to this. So it is divided by our axis of symmetry. And this one is our what? Our matrix. So that, and this one is our f of x equals to 3x squared minus 6x plus 1. So that is how we sketch it. So that is how we sketch it. So we have seen how that graph looks like. We have found the axis of symmetry and the what? The matrix. Now we need to look for other points so that we can plot this graph. So we need to look for the x-intercepts and the what? And the y-intercept. The x and the y-intercepts. Any question up to that? So we need to find the intercepts of a parabola. Now, if we have the function f of x equals to ax squared plus bx plus c. Now, to find the y and the x intercept, then to find the y intercept, then we let x to be equals to what? Equals to 0 to find the y intercept. And I said the y is the same as what? F of x. So f of x will now, x is 0, is now equals to a 0 plus b 0 plus a constant c. So f of 0 equals to what? Equals to c. So our y intercept here will be what? 0 and what? 0 and c. 0 and a constant. That's the way we did last time. We have done this. We have done the y and the x intercept. Now, to find our x intercept, then we let f of x to be equals to what? Equals to 0. We let f of x to be equals to 0. So here, our f of x is 0. So f of x equals to 0 equals to ax squared plus bx plus c. So we have ax squared plus bx plus c equals to 0. Then to get the values of x, how many x's are here? There are 2 of them, right? So to get the values of x, then we can use the methods that we have learned. So either use the completing squares. So to get values of x, then we can use 1 square root of property. Number 2, completing squares. Or number 3, you can use the one quadratic formula. And I say, or you can factorize. I said the best formula, the best thing to use is the one quadratic formula. So you can use quadratic formula in any function. Is that clear? Okay. Now, using the same example here, using this one, f of x equals to 3x squared minus 6x plus 2. Let's find the y and the x intercept. The y and the x intercept. So let's start from the y intercept. This is where we let x to be equals to what? X to be equals to 0. So now it will be f of 0 equals to 3, 0 squared minus 6, 0 plus 2. This one is equals to what? Is equals to 2. Now our coordinate there will now be 0 and what? So this is the y intercept. That is our y intercept. Now, what is the x intercept? What is the x intercept? So the x intercept is now x intercept. So this is where y or f of x is equals to what? Is equals to 0. And this one is equals to 3x squared minus 6x plus 2. So 3x squared minus 6x plus 2 equals to 0. So is this a perfect square? It is not, right? So you can use the AC method. Oh, I forgot to write the AC method. So you can use the AC method. The product is 6. The sum is minus 6. And there are two numbers in each product.
2, 3.
2 and 3.
Or, I'm sorry.
So you cannot find it, right? So you can use the quadratic formula, right? So you can say our A equals to 3, our B equals to minus 6, and our C equals to 2. So let's look for the values of x equals to minus B plus or minus the square root of B squared minus 4AC over 2A over 2A. So our x equals to minus b is minus 6 plus or minus the square root of minus 6 squared minus 4. Our a is 3, our c is 2. All over 2 times 3. So our x equals to 6 plus or minus the square root of 36 minus 1. So 24 divided by 6. And this is equals to 36 minus 24. 12. So 6 plus or minus the square root of 12 over 6. And this is equals to 6 plus or minus to the square root of 3 over 6. Right? Right? And our x equals to, so you can factor out 2. So it will be 3 plus or minus the square root of 3 all over what? All over what? I did it very fast, right? So here, let's factor out what? 2. So if we factor out 2, then our x equals 2. Since we have factored out 2 here, then we remain with 3 plus the root of 3. All over what? 6. Right. So when we cancel this and this, you get what? You get this one. You get that one.
Say the garden plus 1, right?
What's that?
1 plus the square root of 3 over 3, right?
1 plus the square root of,
3/3. Same thing.
oh yeah. So it's the same as x equals to 1 plus the square root of 3 over 3, plus or minus actually. Plus or
Right.
minus, yeah. Plus or minus. So, so those are the values of x. So it will now be the x-intercept will be our x-intercept will be 1 plus the root of 3 all over 2, comma 0, and 1 minus the root of 3 all over 2 and 0. Those are x-intercepts. So now, looking at this sketch here, which we had already sketched, then we have already gotten the value of the axis of symmetry, the vertex. The y will be what? Our y was 0 and 2. So our y is at the point 0 and 2. So our y is at the point 0 and 2. So 0 and 2. And our x is at a point 1 plus the root of 2. So our x will be at this point, and also our x will be at that point. Now, looking at this, it means the root of 3 is what? 1 point something. What is the root of 3? 1 point. 1.1. 1.3 something.
It's 1.7.
1 point?
7.
It's almost 2, right?
Yeah.
So it's almost 2. So 1.7 divided by 2. So it is 1 minus, let's say 0 point something. So it is still positive. So they are here and this point here. So since it is symmetric, so the point from this, and then again, we is also passing through we will see this one. So if it is passing through here, this point 0 for the y and x, and the 0 and was it 2 or yeah 0 and 2, then from that point up to this point here, from this point up to this point here is similar from this here up to this point, which is passing through. So you've identified the points here, the points here, the points here, and the points here, and this one. Now you come and do what? Come and sketch. You come and sketch the graph. So we will see that in the next section, which is section 9.6b. 9.6b. Okay, so so what have we learned here? So, now, what we need to remember is one, the shape of is it facing up or down when a is less than 0 or when a is greater than 0. So you need to remember that. Number 2, you need to get the axis of symmetry. This is where our x equals to minus b all over 2a. So once you get the axis of symmetry, then you can now get the vertex. By now substituting this in what? F of x. So minus b over 2a to get the vertex. So our vertex will be this x here, which is minus b over 2a. And what? And this function here, f of minus b over 2a. So that is our vertex. That is our vertex. Number 3, you now need to remember how to get the y-intercept, where we let x to be equal to 0 and x-intercept, where we let f of x equals to 1 to equals to 0. So those are the basic steps that you need to remember before you now sketch the graph. Now, before we go home, so we can use the discriminant to tell us how many x-intercepts there are on the graphs. So if you remember the discriminant in f of x in x equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. So we say that our discriminant is b squared minus 4ac, right? So this can be used to determine the number of points or the number of x-intercepts, the number of x-intercepts. Now, if that one is equals to 0, if b squared minus 4ac equals to 0, so what are the number of intercepts there? There's only one. 1, right? It is only 1. Because we remember when b squared minus 4ac equals to 0, what is the solution? That's one solution, right? If this is equals to 0, this has one solution. So our x is equals to what? 1. Our x is equals to 1. Now, if this x is equals to 1, then it means that the parabola can be of this form. So it will just come and touch this like that. Okay? Or if it is facing down, or it will just come and like that if it is facing where up, because the x is only one. Only one. Now, if b squared, if b squared minus 4ac is greater than 0, it means there are two solutions, which are what? Which are two real solutions. Two real solutions. So it means that it will either be like that, okay? Because we have two real points here, the value of x, or it can be facing down like this, okay? We still have two real points there. But if b squared minus 4ac is less than 0, then we actually, the values of x are not real, they are complex. So it will hang up there. The values of x will not be anywhere within this region here. So it will be hanging somewhere there. Okay. So next Wednesday, we are now coming to use this, what we have done here, to now sketch. See you guys.